looking at A, what do you think's going on? Like, what does it look like happening?
They're taking the derivative as though the whole bracket is equal to x, but I don't know where the 2 comes from.
Okay, so they're like taking the 4 down here, right?
Yeah.
Going 2x plus 3 and then q. So where could the 2 come from? All right, let's look at another one. So we got the square root of this. Okay, so we would write that as what? X squared minus 5x plus 1 to the half, right? So then same logic, so you put the half there, you do this. Okay, so where does 2x minus 5 come from?
The depth's L.
Oh wait, what was the derivative?
Derivative of, yeah, okay, does that match with this? What's the derivative of 2x plus 3? 2. Okay, so negative 3, 2x cubed minus 5x squared to the negative 4. So what's the derivative of this? 6x squared minus 10x. Okay, so that would appear to be the chain rule, right? Like how we're doing this. So, shall we state our rule in words? So what's the rule in words? All right, so we say like, so each of these guys here is a power, right? So we got fourth power, power of a half, negative 3, and so on. So we're treating it just like we would using the power rule, right? With the base of the thing being whatever's in the parentheses. And then we're taking the derivative, then we're multiplying that by the derivative of what's inside the parentheses. Okay, so let's see, I got some words here. So take the derivative. Take the derivative of the power with respect to the base of the power which for us is just the expression in parentheses, right? That's the base, that's the thing that's being raised to a power. And then multiply by the derivative of the base, multiplied by the derivative of the base with respect to x. Okay, slide that down. So take the derivative of the power with respect to the base of the power. Right, so we're not touching the base. Right? We're just, whatever expression is inside the parentheses, that's just repeated. Right, we're just sort of applying the power rule. But then we multiply it by the derivative of the base with respect to x. Now, the fun stuff is simplifying each of these guys, right? So let's do the fun stuff. So this one, pretty easy to simplify, right? What are we just going to write? Yeah, so we're just going to take 4 times 2, right? Get the 8 times 2x plus 3 quantity cubed. How about the next one? What are we going to do?
Do you do the same thing and just multiply 2x minus 5 by a half?
Yeah, so, well, let's kind of see what have we got, right? So this is a negative a half, right? I mean, it's a little hard to see up here, but on your paper, the negative sign should resolve itself as being separate from. So we kind of look at it, we say, well, so what's in the denominator, right? Well, we got a 2 from the 1/2, and we've got the square root of x squared minus 5x plus 1. Right, so that's what's in the denominator, and what's in the numerator? We got the 2x minus 5, right? So it'll be 2x minus 5 over 2 times the square root of, right? Because we'll go from, if we can express it as a square root, we do. Right? We don't bother with, if it's like cube root, squared stuff, we'll leave powers. The third one, that's going to take a little bit more work. So let's go down here. And, okay, what have we got? Y prime is equal to negative 3. And we got 2x cubed minus 5x squared to the negative 4 times 6x squared minus 10x. Okay, so the 2x cubed minus 5x squared to the negative 4 is going to go into the denominator, right? We'll change that to a positive 4. And then, what will that leave us with? Okay, so let's put the 2x cubed minus 5x squared to the positive 4.
Yeah, then you multiply by 3.
So up top, we have negative 3 and 6x squared minus 10x, but there's a common factor for 6x squared and 10x, right? Which is what? 2x. So we're going to pull a 2x out of here. We're going to multiply it by negative 3. So that's going to give us a negative 6x, right? And then what's left? Well, we pulled a 2x out of here. So we've got 3x minus 5. Okay? Now we're not done yet, because there's a common factor between 2x cubed and 5x squared, which is what? X squared. So we can pull that out. So we're done with the numerator. So I pull out an x squared, and what have I got? 2x minus 5. But what's going on with that denominator? The whole thing is raised to the 4th power, right? So it's not really an x squared. What is it really? It's an x to the 8th, right? Okay. 2 steps away. So we have negative 6x. We got a 3x minus 5. We have an x to the 8th, and we've got a 2x minus 5 to the power of 4. And what's the last thing that we can do?
Cancel an x.
Cancel an x, right? So our final simplified form is negative 6, 3x minus 5 over x to the 7th, 2x minus 5 to the 4th. So you're likely going to see different answers than the one you have, right? And it's just sort of a matter of, did I apply the rule correctly? If you apply the rule correctly, then it's going to simplify down to whatever they have, and you just kind of need to do a lot of practice to get there. And just, this is sort of like the first worksheet, right? Like, what do you need to know to do calculus, right? Which is just a lot of factoring and stuff. Okay, so what's the next one? So the next one, okay, we did this. So the next one is 2 times whatever's in the brackets, right? Times the derivative, and that's got to use the product rule then, right? Because we've got this as a product, right? So it's f g prime plus g f prime, right? So we're using the product rule within this thing, which is the chain rule, which is likely to lead to, a more interesting simplification. So let's start it out. Okay, so that's our starting point, right? That's what we got. That's what the chain rule gave us. And now we got to look at this and say, okay, well, what are we going to do? stuff. So the first stuff could simply be, well, yeah, these three guys are just three terms. They're all factors, right? So let's just write them out that way. So we'll start off by going 2, then the x cubed, then the 2x minus 3, right? And that's just this rewritten as a factor out front. We get inside these brackets, what should we do inside here? Well, we probably have to simplify it and collect terms, right? So we can see, look, we're going to end up with a 6x cubed and a 2x cubed. So we know that we can multiply this out. So what do we get here? 6x cubed minus 9x squared plus 2x cubed. Okay. Now that's going to happen to us every time we do a product rule, right? We're going to end up with some expression with a we're going to have to simplify, right? Okay, so what do we got? 2x cubed, 8x cubed, minus 9x squared. Okay, I like to do these kind of a line at a time, taking my time, right? Like not doing too much at once. Okay, I think if you do too much at once, then things tend to go bad. All right, what's left? Well, we got a common factor inside here, which is what? X squared. So we're going to pull that out. And what am I going to write? So y prime is equal to 2 x to the 5th, right? So we got an x squared that's coming out of here, but we've already got an x cubed, so x to the 5th. Then a 2x minus 3. And then, what? 8x minus 9. And we're done. There's no more common factors. All simplified. So that's, what did we call that on the sheet? The nice form or something? The nice form. Nice. Derivative nice. Okay, so the last one. Let's kick back a couple of pages. So the chain rule says, all right, take the 3, multiply it by this base, whatever's in there, right? We're not going to change it, right? And lower the power by 1. Okay, just apply the power rule. And then do the derivative of what's inside, which, okay, so it's, I like to think of it as sort of like g times f prime minus f times g prime over g squared, right? Or f g of x times f prime of x, etc. Right? It's using the quotient rule. Okay, so let's go simplify that. So it's going to get its own page. And this time I'm actually going to write out the whole thing. So 3 times this thing squared times, and then apply the quotient rule. Okay, so what can we do? Well, we could square the x squared over 2x plus 3, right? And then we can see sort of, you know, part of this is looking ahead. Where are we going with this, right? Well, okay, hopefully, you know, we're going to get something simpler, but, you know, if I square this, then I'm going to be able to multiply these two guys together, end up with a 2x plus 3 to the 4th. We got to simplify this just like we did with part, you know, we got to, what do we get out of that? Okay, so let's do this. So 3, so this is going to be x to the 4th over 2x plus 3 quantity squared. And then up here we've got 4x squared plus 6x minus 2x squared over 2x plus 3 quantity squared. So we can do a little collection of terms here. Oops, okay, so, well, okay, let's call this 3x to the 4th over 2x plus 3 squared. And what do we got? 2x squared plus 6x over 2x plus 3 quantity squared. All right, so what are we going to do? Well, we can factor, what's 2x squared plus 6x? That's going to factor, right? So what are we going to get? Like 2x times x plus 3? Yeah, okay, so let's kind of do that. Okay, so we've got 3x to the 4th times 2x. So that's going to be 6x to the 5th times x plus 3 over 2x plus 3 to the 4th. Okay? And then of course on all of these, right, I mean, you're checking your answer in the back and you're going, why does it look different? You know, what have I done? Maybe you just didn't factor out a common factor or something. Did you bring your new coffee press to work? Why, yes, and I used it today. It's a fancy French press.
It's very dark with such a lighthearted text.
What, it's called Distant Bells or something.
Well, yeah, like it made sense when like Spock
Yeah,
died.
now all we know it is Leonard Nimoy just died.
It's the death knell. Oh, shouldn't. Yeah, now I've got to change. All right, I'll go back to the Star Trek chirp. I had the Star Trek chirp, so that would probably actually be appropriate, right?
Well, yeah, exactly.
Okay, I'll change. But then I won't be able to determine whether it's me or my kid that's getting a text, because that's the one she uses, right? Anyway, all right, we'll do that in a minute. Use your rule to determine the derivatives of each of the following functions. Okay, so what do we do for this first one? Why don't I have any answers for this stuff? So what's the rule? So we're going to go y prime equals what? Come on. 7
times 5 minus 3x to the power of 6 times negative 3.
Oh, wait.
Jake, but I thought we were doing like
Pi.
this little twin thing. I don't know, you don't
5 minus 3. Wow, and then I started writing down the wrong stuff. So what's the nice?
Negative 21 times 5 minus 3x to the power of 6.
I'd say so. Okay, what's the next one?
One half times x squared plus 3x to the negative 1/2.
Okay, so a half x squared plus 3x to the negative 1/2.
Times 2x plus 3.
Right. When we go into the actual chain rule, we're going to formalize it a little bit, and then I think we'll do a bunch of those just so you'll see them that way, and you can use that more formal way. But this is kind of the informal and also tested method. So, and what are we going to do with this? So we know that we're going to put the 2x plus 3 on top, and in the bottom we got the 2, and then the root of x squared plus 3x. Oh, man. I'm going to do the nice forms. All right, so, okay, what's y prime? So chain rule is actually, I think it's kind of neat in a sense, right? So, just, all right, what do we do? Well, 3 times. Copy down whatever's in here, right?
Multiplied by 3 times x plus 1 plus 3x minus 4.
Yeah, I mean, I'd almost rather just expand that and then take the derivative, right? Because, like, you could use the product rule, right? Well, you could just, what do we got? 3x squared, whatever, right? So, like, you don't always have to use the product rule just because, oh, it's a product. But it's pretty easy to multiply out, right? And we know then we use the sum and difference rules, and the derivative is going to be pretty easy to get. So, I don't know. I'll go lazy here. What do we got? 3x squared minus x minus 4. Yeah, 3x squared minus 4x plus 1. Okay, so what's that derivative? Yeah, 6x minus 1. And then I think the only thing, so to make it nice, let's put the 3 first, then the 6x minus 1, and then the x plus 1, 3x minus 4 squared. Let's square that. So in nice form, let's lead with the number if there's a number. Then let's lead with single factors like x squared or x's or whatever. Then let's go to binomial factors and let's go to powers and stuff. I think it's all right. And then man, can we just leave that one for now?
No.
No, damn it. All right. So what do we got? Well, it's easy to do. All right, tell you, we'll do the not nice form because the not nice form is easy. Okay. Well, okay. Not nice form is relatively easy. So what do we need? X squared plus 2x minus 1 times 3x squared minus x cubed times 2x plus 2 over x squared plus 2x minus 1 squared. All right, I'm just going to pause this because there's no point in people watching our pain.
Probably pretty good average.
Yeah, yeah, that's right. Well, it depends. How good are we anyway? Okay, so now we're recording, and so here are the steps. Here's the whatever, not nice form, and here's the nice form. All right. So what? Oh, now we've got the other worksheet, right? Which is the chain rule. It's as if we don't know it. This is kind of weird worksheet order thing because we've discovered it, but now, okay. We know how to determine the derivative of y equals x to the fifth and y equals square root x, but how do we determine the derivative of something more complex, like 3x to the fourth or the square root of 3x squared minus 2x plus 1? We could expand y equals 3x minus 4 to the fifth and then take the derivative of each term, but that would be time consuming and it would not help us differentiate y equals the square root of 3x squared minus 2x plus 1. Or if that was a power of 99 or something. Sure. In order to determine these derivatives, we need to develop the chain rule, which is weird because we already developed the chain rule.
No, we discovered.
Oh, that's true. We discovered the chain rule. Now we can develop the chain rule. So will it be white on gold or blue and black?
Blue
Yeah.
and black.
What's the differentiating again?
To tell the difference between. Oh, wait, you mean in terms of
Yeah,
calculus? Take the derivative.
Take the derivative.
Yeah, it's like you do a search on differential and all of a sudden looking at the back end of a car. Wait a second. There are differential equations, and yeah, it's a car. Yeah, I know, right? And for us, it's all context. Anyways, so the function y equals 3x to the fourth can be viewed as the composition of two functions, right? So I think you spent a good chunk of last semester or the year before doing composition of functions. Y equals u to the fifth, where u is 3x minus 4. Now, we can easily determine dy by du and du by dx, right? So the derivative of y with respect to u, if we're writing y equals u to the fifth, and we can discover the derivative of u with respect to x if we're writing u equals 3x minus 4. How do we determine dy by dx? Is there a connection between dy by du, du by dx, and dy by dx? And if so, what is it? So, yeah, so are we discovering? No, we're developing it now, right? Developing. Who develops stuff anymore anyways? Let's first examine some similar examples. Okay, so if y equals 3u, what's dy by du? What's the derivative with respect to u of 3u? 3. Yeah. If u is equal to 5x, what's du by dx? 5. Express y as a function of x. Okay, so we know that y is equal to 3u, but we know that u is 5x. Wait, you say, no, I'm not. Yes, u is. Which is y equals 15x. What's dy by dx? 15. But wait, we've got a 3 and a 5 sitting around. So what's the relationship between dy by dx, dy by du, and du by dx? What are we going to say? Dy by dx is equal to, yeah, dy by du times du by dx. Yeah, you know, and it's as if these cancel, right? And they don't sort of really, but you can think of it that way. Okay? I mean, those are called differentials, right? Which in the back end of your car is a totally different thing. But, you know, they're like small little bits, right? It's the change, right? Like the change in y with respect to x, the change in y with respect to u, the change in u with respect to x. So why is this relationship true? Well, recall that dy by du is the instantaneous. I think I'll go to Urban Dictionary and put that in. Instantaneous change is is the rate of change of what?
Y with respect to u.
Yeah. So that is dy by du is how fast y is changing with respect to, just keep going with y's and u's. Since dy by du is equal to 3, this means that y is changing, well, okay, don't put the u in quite yet, 3 times as fast as u. Yeah, well, because it's just more efficient in the change room, I don't know. Since du by dx is 5, this means that, not y, u. U is, shouldn't that be UR? I don't know. U is changing, sorry, what goes in? 5 times, just fill it in. If y is changing 3 times as fast as u, and u is changing 5 times as fast as x, then y is changing 3 times 5, or 15 times as fast as x. Or dy by dx, the instantaneous rate of change with y with respect to x is 15. Okay? Example 2. If y is equal to 4u squared, then determine, how does it determine? It's got to be state. Really? I mean, yeah. All right, anyway, so what's dy by du? 8u. If u is 3x plus 4, then what's du by dx? That's 3. Express y as a function of x in simplified form, and then determine. All right, so what's y? So y is 4u squared. But u is 3x plus 4 squared. And we can, you know, kind of simplify that, right? We can just multiply it out. So what do we got? 4 times, what do we got? 9x squared plus 72x plus 16. So what do we got? 36x squared plus, what, 288? Yeah, 288x plus 16. And what's dy by dx then?
Isn't it 24x?
Could well be. Oh yeah, 12. Why did, yeah, somehow I multiplied 3 by 4 and got 36. That's weird. Good thing you guys are there, right? So, okay, what's 4 times 24? 96. 96. It's okay, we would have found out when we went to do the other one and said, wait, they're not the same. So what's dy by dx? Yeah, that thing. Plus, okay, you can do this one.
96.
Plus 96. calculate dy by du times du by dx. Okay, dy by d, let's just do it underneath here. So what's dy by du? 8u, right? And what's du by dx? 3. So what's that? 24u. But what's u?
Question mark.
Yeah, it's a name I call myself. No, it's a name I call him or her or them, because you can be plural or singular. All right, what's u? 3x plus 1. Which is, oh, wait. Oh, yeah, OMG, right? Should I write that in? OMG. Is it true that dy by dx is equal to dy by du times du by dx?
Sure.
Yeah, in this case, yes. Right? I mean, really, can we state that in general? I say yes, it's true. Yes, factorial, emphatically. All right, example 2 of 27. No, I think there's what, 12? The chain rule. Here we go. If u is a differentiable function of x and y is a differentiable function of u, then y is a differentiable function of x and dy by dx is equal to dy by du times du by dx. Okay. So we did it very informally in the beginning with the discovering. We're going to do it more formally for a bunch of examples, and then we'll drop down to the, here's what we do on an everyday basis usually. But I think it's good to see, more formal. And what does this mean, right? It's evaluate dy by dx when x is equal to 3, right? So it's like find it. Find what? Well, what's dy by dx? Okay. It's the slope of the tangent line, right? Or it's the instantaneous rate of change of y with respect to x. So over here, we can say, all right, so when x equals 3, then what's u equal to? Well, we got a formula, right? So 2 times 3 squared minus 3 times 2, which is what, 18, 3 times 3. It's late, anybody watch? Late in the afternoon. All right, what do we got? 9, right? U is 9. Okay, so where do we go from here? So we know that dy by dx is equal to dy by du times du by dx. Okay, so what is dy by du? What's this derivative?
2u minus 3.
2u minus 3, right? This should be easy stuff now. And what's du by dx?
4x minus 3.
4x minus 3, okay? So we got 2u minus 3, we got 4x minus 3. Now we want to work out dy by dx. So we want, whoops, why am I writing that? Yeah, so we want dy by dx when x is equal to 3. Now we've already figured out when x is 3, u is 9. So we're going to take this expression and we're going to substitute 9 for u, and we're going to substitute 3 for x, and we're going to evaluate it. Okay? So what do we got? 18 minus 3. So that's 15. And 12 minus 3 is 9. 90 and 45 is 135. Okay. That's it. We're done. So this was a specific thing, right? I mean, otherwise we'd be putting u in terms of x into here, and we could work out a general formula for dy by dx, okay, which we don't need, right? We're just asked specifically, what's dy by dx when x is 3? If y is equal to 3x minus 4 to the fifth, then determine dy by dx. Hint, let u equal 3x minus 4. Okay, so we're going to say if u is equal to 3x minus 4, then what's y equal to in terms of u? U to the fifth, right? So we're replacing the 3x minus 4 with u, so y is equal to u to the fifth. Okay, now we got a formula, right? So we know that dy by dx is equal to dy by du times du by dx. We've now expressed y in terms of u, so we can work out dy by du, which is 5u to the fourth, right? And du by dx, so we know what u is in terms of x, so du by dx is derivative of this.
3.
3, yeah, it took a while man to get a 3 out of that. So that gives us 15u to the fourth. Okay? And so what we will say, dy by dx, because now we want to replace the u with the 3x minus 4, right? So it's 15 times 3x minus 4 quantity, right, to the power of 4. Which is, in a sense, kind of a lot uglier way of doing it than just saying, hey, it's 5 times 3x minus 4 to the fourth times 3, and then bringing the 5 and the 3 together up front. But this is just more formal, right? We're doing a substitution. We're saying, okay, so we're going to replace that expression 3x minus 4 with u, and then we can work out dy by du and du by dx. And we're going to do the same idea here, right? So if y is equal to 3x squared, the square root of 3x squared minus 2x plus 1, then determine dy by dx. So what should u be? Sorry, okay, yeah. So u is equal to 3x squared minus 2x plus 1. Then what's y equal to? Root u. Or u to the 1/2, right? Because that'll be handier when we do dy by du. Or not, I don't know. All right, so dy by dx is equal to dy by du times du by dx. Dy by du is? Yeah, so 1/2 u to the negative 1/2. Okay. When we go to simplify it, we're just going to do it as 1 over 2 root u, right? But this is a good starting point. And du by dx is?
3x minus 2.
I'm going to go with 6x minus 2.
No, it's 3x minus. I know I'm wrong, but no.
Okay, you're halfway there.
Exactly.
Okay, which is equal to, so now we can sort of simplify this guy, right? 1 over 2 root u times 6, we can factor out a, what are we going to do here? A 2, and get what? 3x minus 1 over 1, right? You don't need the over 1, I like it because it's... Okay, so what do we got? So the 2's are going to cancel, right? So we got 3x minus 1. Okay, so let's say dy by dx is equal to 3x minus 1 over the square root of, all right, now we don't want u in there, right? So 3x squared minus 2x plus 1. So we replace the u with the x expression. Okay, we good? 5/12 of the way there. We do not always have to make a substitution for you, thank God. Right? Sometimes you may want to, so if it's really complicated, you might want to just hang on, let's go back and let's substitute for u and then do this. The chain rule can be thought of taking the derivative of the outer function with respect to the inside function and then multiplying by the derivative of the inside function. This is illustrated in the example below. Right? This is generally the way that we do a chain rule thing. And the thing is, you can stack together as many functions, not stack together, but you can do like f of g of h of I of j of k of x, right? And just start at the outside. That would be really ugly, but you can do 3 of them. Just start with the outer function, right? And when do you stop? When you run out of things to do, right? Now here we're mostly just doing 2, right? It's 3x squared minus 2x plus 1 to the 7th. So determine dy by dx, express your answer in factored form. Okay, so we're going to take the derivative of the outer function, 7 times 3x squared minus 2x plus 1 to the 6th, times the derivative, so we're just going to write it as d by dx of this, right? So we're just going to say it's 7 times 3x squared plus 2x plus 1 to the 6th times, and then we do the derivative of this, which is still 6x minus 2. And what do we say? 6x minus 2 can be factored, right? So we pull a 2 out. The 2, we put it with the 7, so we're going to get a 14. I like this guy first, in other words, the simpler expression, so we'll go with the 3x minus 1. And then the 3x squared plus 2x plus 1 to the 6th. Okay, and leave it in factored form. I mean, God's sakes, you do not want to expand 3x squared plus 2x plus 1 to the 6th, right? That's your binomial theorem. That's pretty good, but still, 6 power, yeah, don't want to go there. So this is really how we want to think about it, right? It's a derivative of the outside function. So what's the outside function, right? It's raising something to the 7th power, right? So it's 7 times that to the 6th times the derivative of the inside function, which is that 3x squared minus 2x plus 1. There's more on this page. Differentiate. F of x is equal to the square root of 3x squared minus 8x plus 2 and express your answer in factored form. So if we want to do this, we should rewrite this as what? 3x squared minus 8x plus 2 to the power of 3 halves. Okay, so f prime of x is equal to, all right, so the derivative of the outer function, 3 halves times 3x squared minus 8x plus 2 to the power of, just checking if you can subtract 1 from 3 halves, to the power of 1 half, times d by dx, the derivative of the inner function, 3x squared minus 8x plus 2. Okay, I write that down. If I'm actually doing this thing, I'm probably just taking the derivative. But yeah, it's good to show you, remember, this is what we have to do, right? We have to take the derivative of the inner function. Which is, okay, so you should be able to do this. 3 halves. It's 6. Okay, and then I can pull a factor. What comes out of 6x minus 8? A 2. 3 halves times 2 is 3. Right, so we're just going to get 3. We've got, now I like this guy next, right, because it's a simpler expression, right? We took a 2 out of there, so what do we got? 3x minus 4. And then we've got the square root of 3x squared minus 8x plus 2. Okay, so we got a 3, we got a 3x minus 4, and we've got a square root of 3x squared minus 8x plus 2. That's basically how it should look in the back of the book, right? All right, what does this say? If y equals f of u is a differentiable function of u, and u is equal to g of x is a differentiable function of x, then y is equal to f of u, almost unfortunate wording, which is equal to f of g of x, right? It's just a composition of functions. and is a differentiable function of x, so we've got this notation we've been using. Dy by dx is dy by du times du by dx. These kind of cancel. You could think of it in your head. They don't really, but, you know. Or d by dx. So when I have this, right, so I've got an inner function, because this is really what it kind of looks like, right? It's a function, and then there's an inner function. So it's f prime of u times g prime of x, which is really, so this is how I think of the chain rule. It's the derivative of the outer function, and the inner function just stays there, right, whatever it was, times the derivative of that inside function. Okay, this is what I, when I'm thinking of chain rule, this is what I'm really thinking of. Differentiate g of t is equal to t squared plus 1 cubed times 3t minus 2 to the 4th. All right, we have a product. We're going to have to use the product rule. But in order to take the derivative of the first term, which is t squared plus 1 cubed, we're going to have to use the chain rule. Right? So each derivative that we take, which is the derivative of this and the derivative of that, we're going to have to use the chain rule. But to do the derivative of that whole thing, we're using the product rule. Okay. So let's do it. So g prime of t is equal to, okay, so product rule says take the first function, which is t squared plus 1 cubed, t squared plus 1 cubed, and multiply it by the derivative, and it will be with respect to t, right? d by dt of 3t minus 2 to the 4th. And to that, we want to add the second function, right? So I take the second function, which is 3t minus 2 to the 4th, times the derivative of the first function, so the derivative of t squared plus 1 cubed. Okay. So really all I've said is, hey, we're doing the product rule, right? So it's f times g prime plus g times f prime. So now we can do it, right? So we've got t squared plus 1 cubed times this derivative. Okay, so what's this derivative? Well, what's the first thing? We're going to take the 4 out front, right? So it's going to be 4 times, I'm just going to throw the 4 in bracket. I'm going to bracket everything to, so I'm not writing numbers beside each other or something. So 4 times 3t minus 2 cubed times what? Times 3, right? So this is actual chain rule, real life chain rule, right? Because we could say times and then do the derivative of 3t minus 2, but really, okay. So it's 4 times this cubed times 3, okay, plus. All right, we got a 3t minus 2 to the 4th, and now we want the derivative of this guy, so it's what? 3 t squared plus 1 quantity squared times 2t. Okay? Perfect, right? Now we gotta do is clean it up. Okay, clean up on aisle. All right, what do we got? So I'm just gonna pull the numbers, right? Okay, so I've got 12, and I don't need a bracket on the 12 now because it's 12. And I've got a t squared plus 1 cubed, and I've got a 3t minus 2 cubed plus, okay, and I've got 6t, that's the letter t, not 6d. So 3 times 2t is 6t, times, and let's put them in the same order, so t squared plus 1 squared, and 3t minus 4 to the 4th. Okay, now we should be able to pull the common factor, right? So what number goes into 6 and 12? 6. Okay, so we got a 6. What's the lowest power of t squared plus 1? It's the squared one, right? So the common factor is just always the lowest power of whatever's there. So this expression is common, and what's the lowest power of 3t minus 2? I'm gonna go with cubed, right? So I got a cubed here and I got a 3t minus 4 to the fourth. So the common factor, the one that's going to divide into both of them, is 3t minus 2 cubed. Okay, so that's looking at the two expressions, right? I've got the expression in front of the plus sign and
Where
behind.
did 3t minus 4 come from?
I don't know, it came from here.
Shouldn't it be
What
3t
should that-
minus 2?
3, oh, yeah. Okay, it's still a 3t minus 2 cubed out front, right? Okay, so what's left? What do I need to get a 12 here? So I got a 6, I'm going to need a 2, right? What do I need to get a t squared plus 1 cubed? I'm going to need a t squared plus 1 to the 1. What do I need to get the cubed? I've already got that, so I'm good, right? Then plus, okay, what do I need to get a 6t? Make sure your t's are distinguishable from your plus signs. Right? That's why my t's always have a little tail curling up. I've already got the squared. I need a fourth power here, so I'm going to go 3t minus 2 to the 1. Okay, so now we're just going to clean up the inside the square brackets. Right? We're going to get an expression there. Okay, rest of the stuff is just along for the ride at this point. Okay, what do we got? 2t squared plus 2 plus 3t squared minus 2t. So let's just expand and collect. We've got at most 2 more lines, I guess. Three t minus 2 cubed. Okay, what do we got? 5t squared minus 2t plus 2. I think we're done. We'll just round bracket this. 5t squared. Okay, there we go. That's the, what do we call it? The nice form? Yeah. It's a nice form. Fully factored. Here, let's scooch this up so you can see the, there. You can see the whole thing at once. Right, so it's just product rule, but in order to do any of the derivatives, we have to use the chain rule. Okay, and then we got to go in, we got to clean it up. Right, we just have to collect like terms, we factor out like terms. We really only have 2 terms, right? Terms are just things separated by a plus sign or minus sign. Determine d by dx of x squared root 1 minus x squared. It's another product, right? It's doing the same idea, right? So d by dx of this expression, x squared, maybe I'll just rewrite this like this, is equal to, okay, so we're going to do the same thing, right? We're going to put some detail in here. We're going to say it's the first term times the derivative with respect to x of the second term. Okay, so we're applying the product rules. First term times the derivative of the second term, plus the second term, so 1 minus x squared to the half, times the derivative with respect to x of the first term. I don't need brackets there. All right, carry on. So here, I'm just going to pause this.
Isn't the last term x squared?
Oh, 2x. Okay, wait.
And then the derived form is 2x.
Yeah.
Actually, x squared.
Oh, sorry. Derivation, yeah. Derivative of x squared. So that's a 2x. So that's a 2x. Woohoo. All right, that's cleaned up. Okay, now what's the common factor? So we got an x, and we got a 1 minus x squared to the negative a half. Okay, lowest power of the expression. So we're going to have a negative x squared here. Yeah, and we're going to have a plus 2x times what? What goes here? So what do I multiply this by in order to get this? Okay. A to the negative 1/2 times something is equal to a to the positive 1/2. Okay. A to the 1, right? Negative 1/2 plus 1 is positive 1/2. So this is going to be 1 minus x squared. Yeah? Okay, so remember, what are we doing? We're factoring out, so I've got a common expression, right? 1 minus x squared to some power. What do I factor out? The lower power. What's the lower power? The negative 1/2. Okay, so x, 1 minus x, well, okay, at this point, let's do this. X over the square root of 1 minus x squared, right? Because that's what that is. Okay, what do we got here? Negative x squared plus 2x minus 2x cubed. All right, so I could take an x out of there, right? Take an x out of here. Maybe we take a negative x out of there. I'm thinking take a negative x. Did I mess it up?
Shouldn't you have gotten rid of the x in the second part of that when you factored out the single x, so it should just be,
Oh, you're right.
yeah,
Yeah, so this x, yeah, this shouldn't be here.
yeah, that should just be a 2, right?
Good thing you guys are here, right? Plus 2 minus, what's that? Minus 2x squared. All right, so let's 2 more lines. Let's clean this up. Actually, I can go over here. Okay, what do we got? X over the root of 1 minus x squared. So what do we got? Negative 3x squared plus 2. That's pretty much what we got, right? All right, let's pull the negative out. So negative x, 3x squared minus 2. There. Okay, so negative x, 3x squared minus 2 over the root of 1 minus x squared. All right, we're 9/12 of the way there. Differentiate h of x. So what do we have to use here?
So many rules.
Quotient rule, right? So we're going to start by just saying it's 4 times whatever's in the brackets cubed times the derivative of that expression, right? So h prime of x is 4 times, okay, whatever we got in the brackets, 3x minus 1, x squared plus 3 cubed, times the derivative with respect to x of that inner function. Okay, so 4 and this. And now we got to do a quotient rule, right? So how does that work? It's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. Okay, so we just got to clean this up. And what do we got? 3x squared plus 9 minus 6x squared plus 2x plus the cube up there. Negative 3x squared. Okay, don't like negatives in there. So let's go negative 4. Let's go 3x squared minus 2x minus 9. Let's go 3x minus 1 cubed over. Why did I put an x in here? It wasn't one to begin with, so there shouldn't be x squared plus cubed. Couldn't do better myself. All right, 2 more. Remember, tomorrow's work period.
Yeah, wait.
What?
Um, since you times the second term started by the power of 3,
Yeah.
like, wouldn't it be like to the power of 5 on the bottom?
Oh,
3x minus 1.
good catch. Nice. I wish I could say I did that on purpose. Or that I actually looked at my answer, which has a 5 in the bottom. It's okay. All I said last year was, just make sure that we have something that comes out clean in the end. Example. If h is a differentiable function, then determine the. Okay, this one's actually kind of easy because it's just notational, right?
We don't on the previous page.
Oh, no,
That's
it's
what
back.
it
It's
is.
back. Oh,
Oh, okay. Sorry,
This
I
is
don't
our
know.
8. We have
Of
14
course.
total.
Really?
Yeah.
Oh,
Why,
I don't.
Why change it like that?
How is there 8?
Oh, this is 8.
And then we still have 12, 13, 14 after that.
Oh my god. Alright, well, I don't know what we're gonna do. Okay, so this is 8. I don't even know what the other ones are. Alright, so what is this, right? So determine the derivative. So f prime of x. So it's 3 times h of x squared times h prime. Right? Just times the derivative of x, h prime of x. And g prime of x is equal to h prime of x cubed. So derivative of that, we don't have a power up there, so we don't know what to do with that. And the inner term is 3x squared. Right? So there's a difference there. One is it's h of x quantity cubed. So we take its derivative, right? 3 times h of x squared times the derivative of the inner function, which is h of x. And here we just have h of x cubed. So it's h prime of x cubed times the derivative of the inner function. Okay, what's the next one numbered for you?
Number 12.
12? Okay. 12 for me as well.
Oh, boy.
Yeah, I don't know. There's nowhere near enough room to do this here. Okay, hang on.
13, 14.
Yeah, I don't even know what I'm doing with those. Okay, there. Extended page. All right, so what do we got? I guess maybe what we should do is rewrite this, right? So x plus x squared plus 1 to the half all to the half. So what's the outer function? Right? It's 1/2. Or it's taking the square root of whatever's in the brackets, right? So y prime is 1/2 times whatever's in the brackets. X plus x squared plus 1 to the half to the negative 1/2 times the derivative of whatever's inside. So d by dx of x plus x squared plus 1 to the half. So it's going to be a chain rule within a chain rule, right? Like it. Okay, so I want the derivative of this. So this is a sum, so what's the derivative of x? Just 1, right? What's the derivative of x squared plus 1 to the half? Got to use the chain rule, right? So to do this, it's 1/2 x squared plus 1 to the negative a half times what? 2x. Okay? So in order to do the derivative of the inner function, we had to apply the chain rule again. Okay, all right, so this 2 is going to take out this 2. So we've got 1/2 x plus x squared plus 1 to the 1/2 to the negative 1/2. And we can clean up what's in here. So we've got a 1 plus, the 2's are gone, so we've got an x times x squared plus 1 to the negative a half. All right, so let's turn stuff into square roots. So I've got 1 over 2 times, let's clean that up. So 1 over 2 times the root, right, that negative a half. So it's going to be the root of x plus x squared plus 1 to the half. Well, it's the root of the root. That's just the original thing, right? The root of x plus the root of x squared plus 1. Times 1 plus, and what do we got? X over the square root of x squared plus 1. We got to expand the page yet again.
What first step?
Okay, so we got to add these guys, right? So this is like 1 over 1. We're going to have to make it root x squared plus 1 over root x squared plus 1, right? To give these guys a common denominator. So 1 over 2 root x plus root x squared plus 1. And this will be root x squared plus 1 plus x all over root x squared plus 1. Okay, so that's just common denominator to add those two together. And then we just multiply the two together. Let's do that here. So up top, we've got the root of x squared plus 1 plus x. And on the bottom, we've got the root of x squared plus 1. Oh, sorry, we got a 2. Let's put that first. We got a 2. Then we've got a root of x squared plus 1. And then we've got a root of x plus the root of x squared plus 1.
Wait, is that the final answer?
That is the final answer. That's what you're going to see in the book, right? And you're just going to say, how am I supposed to get whatever it is I have? Like the actual first step of the chain. I mean, it is a little more difficult, right? Because you've got chain rule and then chain rule within that. You know, really, it's just a series of steps to follow, right? You're just kind of going through that. All right, I got nothing else, so I don't know what to. Where did this come from? So table of values is shown. Yeah, well,
We actually can't do it right now.
well, we can. We just don't have very much time. Do we? Like no time. No time left for you. All right, here's what I'll do is on here. So I'm gonna or I'm not going to say done. I'm going to. All right, so example 13. If h of x is equal to f of g of x, determine h prime of 1. So h prime of x, by the chain rule, is f prime of g of x times g prime of x. And we want h prime of 1, so that's f prime of g of 1 times g prime of 1, which is f prime of, okay, so g of 1 is 2, times, and g prime of 1 is 6, so times 6, and f prime of 2 is 5, so 5 times 6 is 30. Okay, now let's get out the eraser and go clean these guys off. Okay, and go back to the pen. If h of x is g of f of x, then determine, okay, so same deal, h prime of x will be g prime of f of x times f prime of x. H prime of 1 is g prime of f of 1 times f prime of 1, which is g prime, so f of 1 is 3, so it's g prime of 3, and f prime of 1 is 4, and g prime of 3 is 9, and we get 36. All right, so that is example 13. Example 14. Okay, so we have f and g are the functions whose graphs are shown. U of x is f of g of x. Determine each of the following if they exist, and if it does not exist, explain why. So u prime of 1. U prime, let's do u prime of x, which will be f prime of g of x times g prime of x, and u prime of 1 is f prime of g of 1 times g prime of 1. Okay, so that's f prime. G of 1, so here's g of 1 is 3. So we need f prime of 3, g prime of 1, so that's this slope, and this slope is 1, 2, 3, negative 3. So f prime of 3, that's the slope of this line, which is down 1, 1, 2, 3, 4, so negative 1/4 times negative 3, which will be 3/4. V prime of 1, so v of x is g of f of x. V prime of x is g prime at f of x times f prime of x. V prime of 1 is g prime of f of 1 times f prime of 1, which is g prime. Okay, so f at 1 is 2, so g prime at 2, and f prime of 1, so there's f of 1, so the slope of this line, which is 1, 2, 2/1, times 2, g prime of 2, f at 1, Yeah, G prime. Now, you notice here, this does not exist. G prime of 2 is a kink. So this does not exist, and therefore V prime of 1 does not exist. Right, since G prime of 2, the slope of this line, and we have a kink here, or V shape, so that does not exist. W prime of x will be G prime of G of x times G prime of x. W prime of 1 is G prime of G of 1 times G prime of 1. So G at 1, shall we go clean up a little here? Yeah, okay. G of 1 is 3, so that'll be G prime of 3, and G prime of 1, so the slope of this line, I think we worked that out, right? That was up here, is negative 3. G prime of 3, here's the slope of this line, so 1, 2, 1, 2, 3 is 2/3 times negative 3, which gives us negative 2. Okay, and that's that, so we can